Next paper ID is paper ID 183. Are you present?
Good afternoon everyone. I am Anupam Tiwari and my paper ID is 183, and the topic of my presentation is blockchain enabled Internet of Vehicles on distributed storage. Now as the title says, there are three key words here. One is blockchain, one is Internet of Vehicles, and the other is distributed storage. So in this distributed storage, blockchain and Internet of Vehicles, my paper discusses a general introduction of what Internet of Vehicles is. So that basically pertains to a network of vehicles equipped with sensors, softwares, and various number of devices, so that all these devices among the vehicles are able to communicate with each other, exchange data, and take relevant good decisions. Then the next thing that I had discussed is the permissioned blockchain. Now permissioned blockchain is a blockchain which has the typical characteristics of immutability, transparency, security, privacy, granting granular controls, but the thing is that it is permissioned. Permissioned in nature means, like, unlike a Bitcoin blockchain or a Ethereum blockchain wherein the consensus is permissionless, anybody can join, but here in the Internet of Vehicle blockchain that I am proposing here, the things are permissioned. Everyone on the blockchain, while he wishes to participate and do a transaction, he has to be authenticated prior with his private key, public key, that kind of set. The third thing is distributed storage. Now distributed storage, these three terms, distributed storage herein refers to wherein we have got a data, we divide that data into chunks, and that chunks are stored geographically at different locations. Now as we move ahead in the presentation, I'll be able to make it amply clear of what basically all these three terms associate with and how they give us a accrued advantage over the existing models. So why the need of permissioned blockchain? Now we do not want a environment wherein anybody can join. We do not want a Internet of Vehicle system wherein anybody can join without any authentication or verification. So they have to be authenticated users. So that is why permission is there. Then everyone has to have a unique identity for better transparency. Ease of access should be there, and it will be this permissioned blockchain will be able to impart privacy and granular access controls. So it makes a whole lot of difference when we impart all these characteristics to a blockchain that we propose. Why am I proposing here distributed storage? Now there are reasons to it. Blockchain is not meant for any kind of storage. Blockchain is meant for exploiting and imparting typical characteristics of immutability, transparency, privacy, and other multiple functions. But blockchain, when we try and associate with any of the other domains, medical, healthcare, or logistics, or smart buildings, or smart cities, anywhere, all that kind of big data, whatever we are expecting that data to be exploited and checked on blockchain, that is so huge in size that it cannot just be populated on the typical blockchain. So is the need of distributed storage. So while blockchain has been imparting the decentralization part, distributed part, but in all the models, I will discuss it ahead, as in the current models, whatever have been proposed in various Internet of Things models, smart buildings, smart cities, all the works have been basically moving around associating blockchain and the model, but at the same time the storage part is given to the clouds. And it is here that I have proposed a model wherein this centralized cloud storage part can be undertaken with the help of a distributed storage. So these are all the current works, few of the current works that I have discussed in my paper, and I'll not discuss all these papers, but I'll be able to give the basic crux that all these models, they have given out absolute good models, absolutely unique models to associate Internet of Vehicles and blockchain. But as I said, the storage part is absolutely left to the cloud things, absolutely given to the third parties, which should not be the thing. If we are looking for a blockchain exploitation, blockchain characteristics, then we have to go ahead for just not decentralization in the blockchain, but also everywhere in the associated domains also. So like this, in a typical Internet of Vehicle module, So these are the basic subsystems that I have identified, and these are just the major vehicle subsystems, and all these major vehicle subsystems have got a firmware interface, have got a different API, and are all modular in nature, and they have their respective attack vectors, network attack vectors. So that means these are all vulnerable. But when we speak about, first of all, I'll propose my model blockchain enabled IOV on distributed storage. So here, like you see on the screen, I have got 6 vehicles here: C1, C2, C3, C4, C5 and C6. These vehicles C1, C2, C3, these all are populating their respective data at the time of while they are in motion. They have their speeds, they have got their battery drainage, they have got their brakes applied, they have got their cruise control, etc. There are a whole number of things. When a vehicle is in motion, it is populating a number of data. Now all that data is being published to the IPFS. IPFS is kind of a distributed storage, one of the kinds of distributed storage, and what is being populated on the blockchain is the hashes of these IPFS protocol, like I will be showing you in the presentation ahead. So once these data is populated, we publish it to IPFS. IPFS hashes are populated into the blockchain. Now how have I done this? I have used a few softwares which I have mentioned here: Ganache, Trufflesuit and Ethereum blockchain. Then I have also used IPFS storage, the IPFS protocol. Schema setup: I have simple hardware and software applications as seen on the screens. Out of the hardware, I have been able to make out 4 virtual machines, which I have intercepted as I have simulated as the vehicle nodes. Now all these 6 sets of vehicles that I have used, I have identified them with the help of a public key and a private key, which have been exclusively given to the blockchain only after these have been verified and issued per vehicle by the trust center. Table 2 down below, what you see here, these are token exchange set parameters when a vehicle is in moving. Now it is just not that we are simply populating blockchain data on the blockchain, but there are a n number of parameters like overspeeding, traffic light violation, car lights not working, driving inebriated state, driving discipline, etc. There are multiple points to it. All these points that are tokens, crypto tokens. So there will be, while a vehicle is in motion, if it is adhering to driving discipline, there will be 2.5 crypto tokens which will be issued to them. Similarly, so I have generated about 104 blocks. So here you see an extract of the sender address, the credit vehicle address. So anytime you have, he is driving good, he is given some tokens which are populated against his account, and the transaction mining fees as you see on the screen. So all these, the final details that I could accrue after simulating all these car 1, 2, 3, 4, 5, 6, while they started with initial 50 ethers, that is the simulated Ethereum blockchain that I have worked on, they started with initial 50 ethers. By default, every vehicle was issued 50 ethers. After driving and after some simulation, they were able to get some final points, final ethers, 57.7349, etc., as you see on the screen, and the number of total blocks which were generated were 134. Apart from this, in this ecosystem there is a parallel thing which is going on, that is a smart contracts deployment, and these are these 3 smart contracts which I have been able to deploy on the blockchain, which I will show you in the next screen, the extract of the screenshot. So brakes, route and speed. So all these smart contract functions that you see, they have been written in Solidity language. These are sample programs which have been deployed on this blockchain that I am talking about. So this is one screenshot that I have taken from the Ganache blockchain that I have populated. All the vehicles, these are duly annotated, and in case time permits, I'll be able to impart some extra time after the my stipulated 9 minutes, 8-9 minutes. So in this screenshot basically gives out details of the deployment address, where that smart contract per vehicle has been deployed, where are the public keys, how the transaction hashes are being generated, what are the total number of blocks, etc. And after doing all this, now I'll come to the results part. Now this is a very interesting thing. There are few interesting things have come up. So experiment, whatever model that I had shown you in figure 2 right at the beginning, so all the experiments conducted a simulation, and they worked as a proof of concept perfectly. None of the data sets once populated in the blockchain would be subject to possible malicious modifications. Three smart contracts, as I had shown, they were deployed successfully on this blockchain. IPFS storage successfully implemented, and output hashes derived as reference points to get data. Now, I'll just show you a figure in the next page. So these are the sample hashes which were generated against the data. Now, at the first instance, while anybody hears about distributed storage and hashes, he may not be able to assimilate, but a schematic representation I have given. Internet of Vehicles data sets. Now, this is a data set. This is converted into respective binary. All this complete binary of a sample data set is converted into chunks. All these chunks are 256 KB each. These are then converted into respective digest, that is the SHA-256 currently in use in IPFS, and then their respective CIDs are generated. CID is the content identifier. So content identifier, once it is generated, then at the final instance we get the base CID. So of all the chunks, of all the digest, of all the CIDs, we get one final figure, that is the base CID, that is the base content identifier. And this is what how a distributed storage works like. With respect to the data uploading, data population, it is interesting to note that as you see on the screen, if the data set is 10 MB, 100 MB, 1 GB, 2 GB, and I have taken all these down up to 73 GBs. As we increase the RAM, there is a linear relationship which is seen here on the screen, and in case we try and assimilate the same from the graph, what we see is that as the data sets increase in size, the delay increases. There is a delay, subsequent delay, and these delay is absolutely troubling to say 300 seconds, 400 seconds. So that means about 4, 5, 7 minutes. That much of amount of time is taken, and in a Internet of Vehicle ecosystem, which is envisaged, which is something envisaged in future, there will be zettabytes of data which will be uploaded. So I have discussed that in the challenges and future scope. The challenges and future scope are blockchain platforms. Now there are multiple models which are being used by the researchers across Ethereum, blockchain, Cardano, Bitcoin, Fox. There are so many blockchain platforms, but these are all incompatible with each other. Then there is a problem of interoperability. Interoperability means if I have a blockchain platform, you have a blockchain platform, both these blockchain platforms, there are teething issues that they will not be able to speak to each other. Standardization is missing. Identification of nodes and devices, again this is a very separate kind of a research area. Identification of nodes and devices, how do we identify these vehicle nodes? Security and privacy issues in IPFS. The hashes, in case now hashes are plain text, so in case you are able to get my hash, so that is absolutely, you will be able to see the information. But here the research work currently on is that you can encrypt before you upload it to IPFS. Delay issues, as I have discussed, and then as I have mentioned also, that 175 zettabytes kind of a storage is expected by 2025. So another about 4-5 years. So how much, in case we are looking to remove this cloud factor, and in case we are looking to hand it over to any kind of distributed storage, so that kind of storage should be there among the nodes. And communication availability, so it is inevitable that everything is connected onto the internet, so location will have its perfect impact. So in case internet is there, Wi-Fi zones are there, the ecosystem is supporting that kind of a network bandwidth, then of course. But in case we go to some remote village, so there again there will be problems. And these are the references that I have used. In all there are 28 references. So here I am. Thank you.
Thank you so much. Sir, if you have any question.
Yes, Anupam, very nice presentation, and you have elaborated each and everything.
Thank you, sir.
Yes, very good presentation. My only question is, suppose there are some applications, means how you will deal with the latency critical applications.
Sir,
and
this
maybe
is,
there are some complexity in the wireless, maybe there are some heterogeneous networks. So in that case, how you will handle this?
Sir, in the paper, in the challenges also, and also in the paper, this is there, that communication thing that I had mentioned, that basically pertains to this only. There, I have assumed a lot of things while working on associating these three things: blockchain, Internet of Vehicles, and the distributed storage. I have assumed so many things that everything will be absolutely okay, which of course, as you rightly pointed out, which these there will be issues, the delays will be there, and that availability factor will be there. So these are imminent challenges, sir, for which we need to work ahead.
Okay. Okay. Thank you. Thank you
Thank
very
you very
much.
much, sir.